So today I'm going to talk about another one of these topics that everyone uses on their system, but you probably don't spend that much time thinking about, and that is partitioning. So let's say that you clicked on this video and you have literally no idea what a petition is, you don't know what a petition table is, you don't know why you'd petition, you don't really know even what a petition is. So let's say that you have a hard drive that is 1,000 gigabytes and you want to have two independently managed subsections. Now, each of these independently managed subsections would be a petition. And let's say we want one of them to be 700 gigabytes and the other one to be 300 gigabytes. So now we have one petition that is 700 gig and the other one that is 300. But we're not limited to just having two. We could have 4, we could have 5. We could really break it down as much as we want, assuming that it can fit on the actual drive with the petition table alongside of it. So I'll talk about petition tables in just a bit, but you could break it down to say, I want 1,000 petitions for whatever reason, and have each gigabyte of the hard drive be its own petition. Now, this wouldn't really be that useful, but you could do it. Now, I did mention petition tables just a bit, but I'm not going to do much on these because they kind of deserve their own topic by themselves. Basically, what a petition table is think of it as a list of all of the petitions on your drive and where to actually find them. So on Linux, there are two main petition tables that you see, and that is GPT and MBR. Now, GPT stands for GUID boot record, and MBR stands for master boot record. I'm not going to go too much into these just because they are very big topics by themselves, but if you have a system that requires UEFI, you're pretty much going to be required to use GPT. If you have any drives that are bigger than 2 terabytes, use GPT. If you're using an older device, like an older ThinkPad, something that is running a legacy BIOS, and something that doesn't have a big hard drive on it, you're going to be fine on MBR, but there's no reason why you couldn't run GPT on that instead. So we know what a petition is. It's a subsection of a drive, and we know what a petition table is. It's basically a list of all the petitions so that your operating system can find them. But why would you want to petition? Because wouldn't the petition table just be a bunch of wasted space that really isn't doing anything that productive? Why not just put everything in one big petition? Well, one thing about the petition table is it's not really that big, so unless you have a very, very limited amount of space, so you're running drives from the 80s, in that case, I guess there's no point petitioning because your drives are that small, but on modern hard drives, the size of the petition table is so small compared to the actual drive that it really doesn't matter. So what about the benefits of petitioning then? So let's say we have just one petition on our drive, and we decide, okay, we're going to install Arch Linux on it. But then we later decide, I guess I want to dual boot Windows. Well, if we just have one petition on this drive, we can't install a second operating system on it because the computer won't be able to decide which bootloader to actually use. If we try to install Windows, or really any operating system for that matter, it's going to try to wipe the petition because otherwise the computer won't be able to work out which bootloader to actually use when you're starting up the system. So what you want to do in this case is either buy a second drive, or let's say you don't have the money for a second drive and you have a really big main hard drive. What you could do instead is split this main hard drive into two petitions. So you have the Arch Linux petition and you have the Windows petition. And then let's say down the line you decide, I don't actually need this Windows petition anymore, and decide to replace it with something like Linux Mint. Well, what you can do here is completely wipe that second petition and then reinstall Mint, and none of the Arch files are actually going to be affected. So you can do whatever you want to that second petition and nothing on the first is going to be affected. So it's sort of like having two separate drives actually installed on the same drive. Now, obviously, if you want actual separation, having two drives is going to be better, but if you don't have the money for it, or you just have one really big drive that you want to split up, it is fine to actually do petitions to do that instead. Now, another reason you might want to have a petition is for your swap space. So let's say you don't like the idea of having a swap file because, I don't know, you don't want to set it up, or you're using a file system like btrfs, which kind of has limited support for swap files, and you'd rather have something that you know actually works. So instead of doing the swap file, you'd much rather do the swap petition instead. So in that case, having an extra petition for your swap space actually makes a lot of sense. So if you want to go check out my video on swap space, it'll be up on that corner up there if you want a proper explanation about how swap actually works. Another reason you might want to petition is just to have a logical separation of your files. So let's say you wanted to have a petition for your videos and a petition for your pictures and a petition for your documents. Well, there's no reason why you couldn't do that. Now, I'll talk about the problems with doing that in just a bit, but if you really wanted to do that, there's no reason why you couldn't do it. Something that I've actually had to deal with is reinstalling my OS. So I broke something with Arch Linux a few months back, and because I broke it, I didn't really feel like trying to work out what the problem was, and I decided the easiest fix was just going to be reinstalling Arch. And because of that, all I had to do was delete what was in my boot partition and delete what was in my root partition, and I didn't have to lose anything that was in my home. So even though it was on the same drive, I could just go and wipe those extra partitions and not affect any of my local files. Now, another thing you might care about is having simpler backups. So let's say you want to back up your drive, but you realize there's not really much of a point to back up your root partition because you have things like your application files and the binaries you have installed, and there's not really any point to actually back those up. So what you want to do instead is just back up the home partition. Well, if the backup software you're using only lets you point at a drive or at a partition, if you don't have a separate home partition, well, you're going to have to back up the entire drive. But if you do, you point the backup software at that partition, and you just basically clone that entire partition, and there you go, you've backed up your entire home. So maybe that's something else you care about. And another thing that this one actually does matter for me on this system is installing my operating system across multiple drives. So I've got my root partition on my NVMe drive, and I've got my home partition on my hard drive. And having partitions just makes this a little bit easier to do. Now, there are some minor drawbacks to having multiple partitions, but I don't really think they outweigh all of the benefits. So it does make disk management more complex. So if you have more partitions, you're going to have more things that show up when you run something like lsblk. It's not really that big of a deal. How often do you find yourself trying to manage your different disks? I wouldn't say it's that big of a deal to deal with. Yes, it will be more complex on those rare occasions where you do have to deal with it, but I think the benefits really outweigh this. Now, something that might be a problem, especially if you do have smaller drives, is if you make your partitions too big, you'll end up wasting a lot of space. So let's say you have a videos partition and a pictures partition, and you give, I don't know, 100 gigabytes to the videos partition and 100 gigabytes to the pictures partition. Well, you're more likely to fill up the videos partition than the pictures partition just because pictures are obviously way smaller. So you're probably going to have a ton of wasted space in that pictures partition, which you could have given to something else that might need it. So you could have made the videos partition, say, 150 gigabytes and the pictures 50 instead. But this really just comes with, I guess, being experienced with knowing the sort of data that you tend to store on your computer. If you know that you're going to have way more videos than you are going to have pictures, well, you're obviously going to make the picture partition smaller than the videos one. The first time you try to do it, it might kind of be a problem, but once you get used to it, it's not really that big of a deal. Now, obviously, you could go and partition every single folder on your system, but most of the time, there's not really going to be any point in doing that. Most people end up following some sort of partition scheme, and they fall into three separate categories. So we have the partitionless disk, we have the single root partition, and we have the discrete partitions. Now, a partitionless disk is basically a disk that has no partition table whatsoever. So it has 0 partitions and no partition table, and this is called a super floppy. And most of the time, you don't really see this outside of removable media. You could technically install Linux on a system like that. It's just not recommended because if you were to plug that drive into a Windows system, it's very possible that it won't actually detect that there's any data on that drive. So I would avoid doing that unless you're doing something like a VM. Most of the time, it's probably not worth it. So the bare minimum that most people are going to do is a single root partition. So that is when you have a single partition, so one entry in the partition table, and on Linux, that'll be set to /. And in this case, if you want to have swap space, you're going to have to do a swap file. I would recommend against doing this though, because of some of the benefits of having multiple partitions that I told you earlier. So things like being able to reinstall your operating system without nuking all of your home files, or being able to dual boot on a single drive, and other things like this. You can do it, and if you're setting up a VM, probably fine like that. But like with the partitionless disk, I wouldn't recommend doing this unless you desperately need that extra space. So what I would recommend doing is doing some sort of discrete partition scheme. And there are a couple of places that will typically get partitioned on most Linux systems, or at least they get commonly partitioned. So the one that you usually see 99% of the time is the root partition. So The root partition is where all of your applications will be installed and where your application files and various things like this will be installed. So something like this should be at least 15 to 20 gigabytes, but if you have extra space, I would really recommend giving it to that, especially if you're someone who likes to install games. If you install games and you have a 15 to 20 gigabyte root, you're not installing any modern games. You can install half of Doom. Anything more than that, you're kind of stuck. So if you're a gamer, I would recommend a way bigger root than that, but if you're just installing terminal applications, 15 to 20 gigabytes is probably fine as long as you uninstall stuff that you don't need. I don't uninstall stuff that I don't need, so I tend to fill that up pretty quickly. I think I've got 23 or 30 gigabytes currently used in my root. And the next one we usually see is either a boot partition or an EFI partition if you're on an EFI system. And this will contain the kernel and the RAM disk images, as well as other sort of things like your bootloader and bootloader configuration. Now, normally this one is sort of required. It kind of depends on which partition table you're actually using and whether you're on BIOS or UEFI. And I'll talk about that in just a bit. So if you're not on EFI, this should be at least 200 megabytes. And if you are, then it should be at least 260. I think I've made mine 520, and any more than that is just way overkill. Now, the next one you might see, which I don't have set up on my system, is a partition mounted to /var. So this will contain things like your system logs, your Pac-Man cache, your cron spool, and various other things like this. Now, you might want to separate this out to make sure that system logs don't start filling up your system. But on modern hard drives, on large hard drives, this isn't really that big of an issue. So for example, I don't know how long it will take to get 1,000 gigabytes of log files. So for that reason, I don't really see much of a point of doing this anymore. If you are using an older device, or you are using a device that has a small hard drive, maybe it does make sense to separate this out. But on modern systems, there's not really as much of a point. And the next one you'll commonly see is a swap partition. So there's a couple of recommendations about how big this should be. Either double your RAM, 1.5 times your RAM, 1.25 times your RAM, equal your RAM. It sort of depends on who you ask. If you want to see my recommendation, go check out that video up there because it's not really as simple as this is the one number I suggest. I would recommend at least the size of your RAM just so you can hibernate your system, but if you don't know what swap is, basically, it's virtual RAM. So when you run out of physical RAM in your system will switch over to using the swap to make sure your system doesn't lock up, basically. Now, it's going to be much slower than your actual RAM, but it's better than locking up your system. So we have two more that are usually recommended, and the first one is the /data partition, and this is for files that are going to be shared between the users. But if you don't want a /data partition, you can just use your home to do this instead. And as for the size of home, it should usually be basically whatever's left over. So when I set up my partitions, I do root, boot, whatever else I need, and then home. And then home just ends up being the rest of the drive, basically. And the other partitions you can do are just anything else you want. So if you want a videos partition, if you want a pictures partition, if you want, I don't know, videos /something/something/something, feel free to do that. But at that point, I wouldn't really recommend making it a partition. Now, there's a couple of layout examples available on the Arch Linux wiki, so let's go check those out. So the first one we have here is for UEFI/GPT, which is what I'm using on my system. I'm using this layout here, but my sizing is a little bit different to what's going on here. And the next one we have is for BIOS MBR, which is what I've got running on my laptop right now. And the last one we have is BIOS/GPT. So on a UEFI GPT system, what it recommends is having a /boot or a /EFI partition that is at least 260 megabytes. And as I said, mine is 520. I don't know why I set it to 520, but it's at least 260 megabytes, so it's fine. And then we have a root partition, which is at least 23 gigabytes, and it recommends at most 32, but you could go way more than that if you really wanted to. And then for swap, it recommends at least 512 megabytes, which if you have only 512 megabytes of swap, at that point, I wouldn't even recommend doing it. You should probably do something like a swap file instead and then only use it when you desperately need it. And then for home, that is basically just the remainder of the drive. Now for BIOS MBR, it's exactly the same, except you just get rid of the /boot or the /EFI partition. And then for BIOS/GPT, we bring this partition back, but instead of mounting it to /boot or /EFI, you just don't give it a mount point. And the suggested size is at least 1 megabyte, and this petition here is just here for Grub. So if you're not using Grub and you're using some other sort of bootloader, you don't actually need this petition, but most people are probably going to be using Grub on their system. So let's go and have a look at exactly what I'm doing on this computer. So if I just open up my terminal and I just run lsblk, as you can see, I've got all of my drives here and all of my petitions. So the first one we have is SDA. So SDA is a mechanical hard drive, and as you can see, it is 1.8 terabytes. And on this drive, I just have a single petition, and that single petition is just my home. So my home is separated out into a separate drive. So if my root drive breaks, all of my home data will be perfectly fine, and the same is true in reverse. If my home drive breaks, all of my root data will be fine. I'd prefer that my root drive breaks over my home drive because that would be a little bit more annoying to deal with, but if that does happen in either direction, then the other drive will be safe. So the SDB drive you see here is an SSD. Now I'm not going to go into this drive because this drive right here is a Windows drive and I have no idea how Windows does its petitioning and I don't really feel like learning about it. So the third one we have is NVMe 0N1. So this is an NVMe drive and this is where my root, my boot, and my swap is. So this first petition we have in here is my boot petition. So this is where things like my Grub configuration is and various other things that my bootloader actually needs. The next one we have is my swap petition, and this is basically RAM times by 1.5, which is way overkill in my case because as you can see, that is 48 gigabytes of swap, and I have literally never used that much, so way overkill. I probably could have gotten away with 32, but I set it to 48 because as you can see, the rest of the drive is basically just my root petition, which is 400 gigabytes. Which I'm literally never going to use unless I start filling it up with games. Now, it probably would have made more sense to have something like the videos that I make for YouTube on that NVMe drive, just so it's going to be quicker to edit, but I don't really see that being much of a bottleneck. The bottleneck I see with something like Kdenlive is the fact that it doesn't do GPU rendering. I don't really feel like the hard drive is my slow point. Yes, the NVMe drive would be way quicker, but I don't really see it being that big of a deal. So you may set up your petitions completely different to me, and the next time I build a computer, I'll probably do the same thing as well. But if you have no idea what to do at all and you're installing Arch Linux, what I would recommend doing is just coming over to the Arch Linux wiki and just copying one of these layouts depending on which system you're actually running, whether that is a UEFI GPT system, BIOS MBR, or BIOS GPT. So hopefully that gives you a better idea about why every Linux installation video recommends setting up partitions and some of the benefits you actually get in doing so. So I think that's pretty much everything I want to talk about today, but before I go, I want to thank my patrons. So a special thank you to Joachim, Nathan, Andrew, Montezar, Peter De Road, Tony, Donald, and Zilva. If you want to check out the Patreon, there'll be a link to that down below, as well as my Amazon affiliate links where you can buy the gear in this channel, or anything else you want, and I'll get a small kickback for it. Also, remember to go check out my podcast. That is Tech Over Tea, available on Library and YouTube, and the audio version available wherever you listen to audio podcasts. Also, remember to check out this channel, available on Library, BitTube, and BitChute. And remember to smash the like button and leave me a comment down below. And remember to subscribe and ding the little bell icon down below as well. So I think that's pretty much everything for me, and I'm out.